Hello everyone! Today, I'm going to introduce a revolutionary electromechanical framework that challenges our traditional understanding of light, mass, and velocity, the theory of the path of light, authored by Kautar Khanif. For over a century, modern physics has told us that moving large, macroscopic physical objects at the speed of light is an absolute impossibility due to the infinite energy requirements of Einstein's equations. This theory introduces a paradigm shift. By transitioning from viewing light as a flat linear vector to treating it as a dynamic, three-dimensional geometric volume, c-cubed, we open the door to a propulsion system that can theoretically transport massive structures, even on planetary scales, at the absolute velocity of light. We begin with observations from celestial mechanics. The Moon and Earth provide measurable timing relationships that can be used to study the behavior of light over astronomical distances. These observations serve as the foundation for the theoretical framework presented in this work. Let's start with the foundational observation that inspired this theory, the daily delay of the Moon. As we know, the Moon rises roughly 50 to 55 minutes later each day. While classical astronomy explains this through orbital mechanics, this theory looks at it through the lens of accumulated light wave segments. The light path between the Earth and the Moon takes approximately 1.28 seconds to traverse. When we look at the daily 55-minute delay, we are looking at a concentrated accumulation of these individual 1.28-second beams over the course of a day. The core thesis here is simple yet profound. Because the speed of light, c, is absolute, meaning it does not change regardless of how long the wave runs, we can chain these 1.28-second segments back to back over a 55-minute duration. This slide introduces the idea that light may be analyzed not only by its speed, represented by c, but also by the volume it occupies while propagating. Instead of considering only linear motion, the theory investigates a volumetric interpretation using a cubic scaling of the speed of light. This approach is proposed as a possible way to describe the spatial structure of propagating light. The second part focuses on engineering. Here we examine how electromagnetic gaps and resonance can be optimized to improve energy transfer efficiency. These concepts are important because efficient energy confinement is essential for any future propulsion system. Simply stacking light beams end to end creates a critical engineering problem: discontinuity. Every time a new beam initiates from its shortest wavelength, minor gaps or wavelength faults appear along the path. In a transport system, these faults would destabilize whatever mass is traveling along them. To solve this, the theory introduces electromagnetic induction. When a primary beam traveling at speed c actively induces the next consecutive beam at speed c, their intersection creates a localized field configuration equivalent to c squared. When we take this c squared induction state and combine it with the physical rotation of our machinery, the path expands into a seamless, volumetric c cubed configuration. This entirely erases the microfaults. Now let's look at the actual engineering hardware required to create this volumetric light path. At the heart of the engine is a hyper-precise core reactor that utilizes hydrogen plasma. We use hydrogen because its Balmer spectral series naturally emits all colors across the visible spectrum. Full-spectrum visible white light is vital. It contains all the necessary components to journey safely with the speed of light. This plasma is firmly confined around a core crystal using an electromagnetic penning trap. Surrounding the plasma are precise, hexagonal arrays made of quartz crystal. Quartz is chosen because of its abundance and its incredibly stable piezoelectric oscillation frequency of 32,768 Hz. By varying the physical distances between our electromagnetic coils and the quartz crystal arrays, the reactor generates localized plasma rings known as tokamaks. Forcing these tokamaks to collide is what stabilizes the c-squared induction field we discussed earlier. This entire propulsion unit operates as a macro-scale dynamo generator that bridges electricity, light energy, and mechanical momentum. What makes this revolutionary is its operation. There is no heat, no friction. The third section focuses on resonance. Efficient energy systems depend on matching natural frequencies so that energy can be transferred with minimal losses. By combining resonance principles with dynamo concepts, the theory proposes a method for sustaining electromagnetic oscillations within the propulsion system. When these hexagonal ROMs are vibrated at this exact binary frequency, they act as transducers. They force the surrounding plasma to pulse in a localized wave pattern that locks reflection boundaries at a precise 15 degrees angle. By combining 4 of these hexagonal quartz structures, we establish a completely enclosed, 4-faceted symmetrical light funnel. Since 4 times 15 degrees gives us a perfect 60 degrees geometry, the process follows 4 clear steps. First, rotation initiates. Second, the rotor's vibration triggers high-precision piezoelectric discharges from the quartz crystals. Third, this electrical discharge excites the hydrogen plasma into a full-spectrum glow. Finally, the vehicle transitions this electricity directly into kinetic energy via the Formula 1 half mass times c squared, converting electromagnetic gap energy into linear light momentum propulsion. Our final slide addresses a critical practical question. How does a vehicle utilizing this technology safely escape the Earth's atmosphere without burning up or wasting immense amounts of fuel? The Lunar and Planetary Escape System turns the atmosphere from a barrier into an asset. Instead of fighting atmospheric drag, the system ionizes ambient gases in the upper atmosphere, specifically hydrogen from the Earth's geocorona, and pulls them into the engine as a propulsive plasma stream. Furthermore, as the vehicle pushes forward, its hexagonal light funnel projects full-spectrum white light onto atmospheric water droplets, instantly destroying their surface tension and causing them to burst. Simultaneously, the system takes advantage of the fact that quartz has a higher refractive index 1.54 than atmospheric ice 1.31. This index mismatch generates an optical torque, a literal light push, that forces randomly scattered atmospheric ice crystals to stand perfectly straight, shattering their natural 22 degrees halo alignment. The ice structures instantly collapse and evaporate into clear, harmless H2O vapor. Thank you for your attention. This presentation introduced the theoretical foundations, engineering concepts, and possible applications of the path of light theory. I welcome your questions, comments, and suggestions for future research and experimental validation. The final slide lists the image source used throughout this presentation. These images is included for illustration purposes to support the engineering concepts and astronomical discussions presented today. Thank you once again for your attention.